Okay guys, today we're going to continue to solve quadratics, and we're going to do that with the quadratic formula. But today's answers are not going to be nice rational numbers, they're going to be irrational, so we're going to have some radicals in them. So what we're going to do is we're going to start by solving the equation. We first have to set it to 0. So to do that, we are going to zero out the positive 8, so we're going to subtract 8. We're going to do that from the 9 over here as well. And then we're going to zero out the 7x squared. So we're going to subtract 7x squared from itself, as well as the x squared term over here. Okay, once these are gone, we're left with 0 now. Over here we have 5x squared remaining, plus 5x, plus 9 minus 8 is positive 1. Okay, so we've got our quadratic, it's set equal to 0. Now we can go ahead and use our quadratic formula, but first we need to find what our a, b, and c are. Our a is always the coefficient in front of the x squared, so it's 5 in this case. Our b is the coefficient in front of the x, so 5 again. And our c is our constant, so positive 1. Then we're going to substitute these into the quadratic formula. We start with negative b, or I like to call this the opposite of b. So the opposite of our b value, 5, plus or minus the square root of our b value squared minus 4ac. So that would be our 5 squared minus 4 times our a value, which is also 5, times our c value, which is 1. We're going to take this entire numerator and divide it by 2a. So 2 times 5. Okay, once we plugged everything into the formula, we're going to begin simplifying. So we have this negative 5 plus or minus the square root. 5 squared is 25 minus 4 times 5 times 1 is 20, all divided by 2 times 5 is 10. Okay, we can simplify our radical further. 25 minus 20 is 5, so we have negative 5 plus or minus the square root of 5 all over 10. Okay, then we need to see if we can simplify the square root of 5. Since 5 is a prime number, we cannot break it down any further than just 1 and 5. Neither of those are perfect squares, so this radical is as simplified as it can get. You need to remember that you're taking this entire numerator divided by 10. Sometimes you are able to reduce. In this case, we cannot reduce because the 5 and the 1 cannot both be divided by 10 evenly. 5 tenths could be reduced to 1/10, but we can't just reduce part of this and not the whole thing. So this is going to end up looking like this. Negative 5 plus, we're using the plus here, root 5. You don't have to put the 1 there. You can if you want. All divided by 10. And then this over here, the other answer is negative 5 minus the root 5 all over 10. Okay, so those two are the zeros, or the locations where the parabola crosses the x-axis. So those are the values that we have found. Okay, for example 2, we have another quadratic, and we can see it's not equal to 0 yet. So that's our first step, is to zero out this term by adding 2x. And then we have to take that and add it to its like term over here, which is another 2x. Okay, if we simplify this, we have 12x squared plus 4x minus 3 equal to 0. Okay, this tells us we're ready to do the quadratic formula. So we're going to identify a as 12, b as 4, and c as negative 3. And then we're going to just plug into this formula here. So we have the opposite of our b value, 4, plus or minus the square root of our 4 squared minus 4ac, 4 times our a value of 12 times our c value of negative 3. And then the numerator is going to get divided by 2a. 2 times 12. All right, now I'm going to focus on simplifying what's underneath the radical. So negative 4 plus or minus the square root. I know 4 squared is 16. I know that the negative here times the negative 3 here is going to make this whole thing positive. So it's going to be plus, and then I know 4 times 3 is 12, and 12 times this 12 is 144. All divided by 2 times 12, which is 24. Okay, if I go ahead and add 16 and 144, I get the square root of 160. All of this being divided by 24. Now this radical, I know I can reduce this. And so if I go off to the side here, the square root of 160, I want to try to think of the biggest perfect square that divides into 160. And I know 16 is a perfect square that would go in there. So I know the square root of 160 is the same as the square root of 16 times 10 is how I get 160. So it'd be times the square root of 10. Okay, and then I know the square root of 16 is just 4. And then the square root of 10 cannot be reduced any further. So the square root of 160 is just 4 square root of 10. So if I come down here, I can go ahead and write this as negative 4 plus or minus 4 root 10, all divided by 24. Okay, so I've gone ahead and simplified my radical. The last thing I have to do is see if I can simplify the 4 24ths and this 4 24ths, and I can. I can divide all of these numbers by 4. And so if I do that, I'm going to end up with negative 4 divided by 4 is negative 1. 4 divided by 4 is 1. So this would be the plus or minus 1 root 10. And then 24 divided by 4 is 6. Okay, so I was able to simplify all of that down. You don't have to write the 1 here. And then my two answers will be negative 1 plus the root 10 over 6 and negative 1 minus the root 10 all over 6. Okay, for our third example, here is our quadratic. We're going to zero out these two terms, so we're going to add 11x squared and also add it to the side over here. That'll zero out. We're going to subtract 11x and subtract it from the 8x over here. This will make this side 0. Negative 5x squared plus 11x squared is going to give me 6x squared. 8x minus 11x is going to leave me with negative 3x, and then plus 6. Okay, so now we're ready to identify our A, our B, and our C. Our A is positive 6, our B is negative 3, and our C is, again, positive 6. So we're ready to plug into our quadratic formula. So we're going to take the opposite of our B value, negative 3, plus or minus the square root of our B value, negative 3 squared, minus 4 times our A value of 6 times our C value, which is also 6. And then we're going to take this numerator and divide it by 2 times A, so 2 times 6. We're going to go ahead and simplify. The opposite of a negative 3, or a negative times a negative 3, is a positive 3. Plus or minus the square root. Negative 3 squared means negative 3 times negative 3, and that's going to give us a positive 9. And then we're going to have minus 4 times 6 times 6 is, if I use my calculator, 144. Okay, and then we're going to divide everything by 12. All right, so as we continue, we're going to take 9 minus 144 And that's actually going to get us a negative number. So we're going to have 3 plus or minus the square root of a negative 135, and this is all going to be over 12. Now this is where we need to stop and take a look at something. If I get my calculator out, if I try to take the square root of any negative number, okay, I'm just going to go ahead and type this one in, negative 135. Oops. It says non-real answer. Okay, this is actually going to give us what is called an imaginary answer, and this is something that you'll learn more about in Algebra 2. What you need to know for Algebra 1 is that anytime you take the square root of a negative number, there is going to be no solution. Okay, so now I don't know exactly what this parabola looks like, but let's say it, if there was no solution, that would mean that it would not cross the x-axis. Okay, notice there are no x-intercepts and therefore no zeros, no solution.